This is Accelerated GCSE Unit 17 Statistics. So we're just going to take a quick read through and see the sort of things we can have. So the first bit then is the questionnaires. You can read about the data handling cycle on page 469 to 471 of the textbook. A hypothesis is a statement which may or may not be true. So you start with a hypothesis, and then the experiment then is to decide whether it's true or not. When designing a questionnaire, you must follow these rules. A questionnaire consists of at least 3 or 4 questions. The questions are as short as possible. The questions are clear and precise. The questions are equally balanced. The questions are closed. The questions are not biased. Make sure you know what biased means. Any groups used are clearly and uniquely defined, and there are no gaps in the groups. For example, you don't sort of say, someone, what is your age 0 to 3, and then 5 to 6, where obviously kind of 4 has been left out. So just obviously be careful with that with discrete and continuous data. Balanced definition. So balanced, there must be an equal number of agree and disagree options. Closed, there must be an option for everyone to choose. Biased, if the options are leaning towards a particular gender or age, etc. And clearly and uniquely defined groups. Each response can only go in one group, and there must be a group for each result. Again, the sort of thing we were chatting about. Say you have age groups 0 to 5, 5 to 10, 10 to 15. If the person's 10, it's really unclear about which group then they're going to be in. So just be very clear about that. Questions must be suitable and not leading or suggestive. You cannot let your opinion on the matter be obvious from how you've written the question. So again, be careful about that. It's like, don't you think that golf is a silly game or something like that? You can't ask, all right, because it's giving your opinion, and it's very obvious that what's going on. So 17.2 then, statistical diagrams. So for discrete data is data that can only take a certain distinct value, e.g. numbers of people, shoe size, etc. To draw frequency diagrams for discrete data, you do tally, you convert the frequencies, you display in a frequency diagram or a bar chart. Continuous data that can take any value and is measured, e.g. length, time, temperature, weight, etc. Bar charts, that sort of thing. You should be able to construct and interpret a wide range of graphs and diagrams, including frequency tables. I mean, you've been doing bar charts really since year 8, so we're not spending too much time on these. Frequency diagrams, for discrete data, you do a tally, convert to the frequencies, and display in a frequency diagram or bar chart. So that's kind of what we have here. On then to our next page. For continuous data, you set up your appropriate groups. You define the groups explicitly, so again, being careful not to have overlaps or not to have gaps. You tally the data in the appropriate groups, and you convert them to frequencies, and you display in a frequency diagram. So we have this. Note the difference there between this one and the previous one. So there we have something like A, B, C, D, E, or 1 to 5, 6 to 10, 11 to 15. Over here, this is a continuous scale, 0, 5, 10, 15, 20, 25. One of the big differences then in between discrete and continuous data. Appropriate groups. Groups should be the same size, include all values, not be too big or small. Define groups explicitly. All data can be placed in a group. There is only one place a piece of data can be placed. For example, here, 0 to 5, 5 to 10, we can see 5 in this case is going to be going then in here. Okay, so the frequency diagram below shows the heights of different objects in centimeters. Construct a group frequency distribution table. Give the limits of the modal class. So I've set it up here. Make sure you're using your ruler, obviously, and we're going to go then with heights. If we set it up then in such a way that it's something similar then to this, 0 to 5, 5 to 10. So our first one looks to me that's going to be 7 there. So not less than, I'm just going to go with H because it's H there, obviously. H less than or equal to 7, and then 7 less than H, and to me that goes up to 14. So it looks like they're going up in 7s here, then from 14 to 21, 21, The one looks like 28, and then 28 to 35. Frequency then, I think this one's quite easy to read off. I'm hoping everything's reasonably even. So the first group is 700. The next group is 500. The 14 to 21 group is 300. Next group is 800. And the final group then is 200. So if we total all those up, move this up in just a second, it'll come down to 2,500. I think that's 1,000 there, that's 1,000, yes, so 2,500. Give the limits of the modal class. So the modal class is the one with the most in it. So this is part A. Sorry, I've answered this. Separate this bit out. Part B, then modal class, and the one with the most in it is then the one between 21 to 28. So it's going to be 21 to 28. Give the percentage of heights greater than 14. Sorry, you can't see that. Find the percentage of heights greater than 14. So the ones greater than 14 here are this one, 300, 800 and 200. So that gives me 1,300 over 2,500. And as a percentage then, that's going to come out to be 52%. Finally, give the ratio of the number of heights less than or equal to 14 compared with the number more than 21. So less than or equal to 14, we're going to have 1,200. Number more than 21, then we're going to have 1,000. So you can cancel this down whatever way you want. I mean, you can divide by 100 there and you'll get 12 to 10, and then that cancels down further, 6 to 5.